Alrighty, so that was kind of our... Sorry, I'll put the balance equation with the three-eyed person back. Okay, so this was kind of our handy-dandy cheat sheet, basically, of everything that we're doing right now. So let's keep doing it. Okay, here we go. Let's say we have now... let's do that same one from yesterday. Okay, so this was our chemical reaction for, we did copper and silver nitrate, right? So, let's say, okay, let's say we have 0.15 molar AgNO3. What volume of this solution is needed to react with 25 grams of copper? Alrighty, let me just close the door here. Okay, so which of these numbers, I am recording, yes, this is good. What number do we have that we can start with? So remember, step one's already done. First we balance it, of course. We want to use what we're given to find moles of A. So which one of these numbers will give us moles of A? Yeah, we're going to be using the copper in this case. That's what we're going to start with, because we can get moles right away from that one. Okay? Boom, copper's molar mass I have here, 63.55. So now we use our reaction coefficients. What are we looking for in this case? Which compound? Yeah, we're looking for silver nitrate, yeah. So what are we going to put in the next line there? Oh, let me pause this then. Let's get some of this latency back. Bandwidth fun. Okay. What are we going to put on which one? Mm-hmm. That's okay. That's okay. I know what you're trying to say. Alrighty. Okay, I always like to stop at the moles of our desired substance and then go from there, but you could just take this and keep on calculating. So if we do this, we're going to put 25 divided by 68.55 times 2. So 0.78678 moles silver nitrate. Okay, so now what? What are we going to do now? Moles to volume, indeed. Find L. So we have this other number, the 0.15, right, that we haven't used yet. So we remember this thing is moles per liter, right? And so, if we're trying to find liters, we could say that liters is moles over molarity, right? Or we could just use it as a conversion factor. We know that we have 78678 mole silver nitrate. So, this case, we're going to put the liter on top and the 0.150 moles part on the bottom. So remember, this thing is a conversion factor. The concentration is a conversion factor. This is the same thing as saying this many moles per 1 liter. Okay, so we're just flipping that upside down. And in that case, when we do this, 0.78678 divided by 0.15 is going to give us, wow, that's quite a bit, 5.2452 liters. And assuming we're going to use 3 sig figs, that's going to be 5.25 liters. Okay. Sorry, heading the way. Okay, how's that looking for you guys? So again, as always, we should make sure our units work out. So we're going to end up with moles of silver nitrate. From there, we can use the molarity. No, this one is just a random problem. The one for your experiment is just the one with oxalic acid. So this is lecture stuff now. Alrighty, any questions on this one? Is this starting to make a little bit more sense as to what all of this craziness is about? Yeah, you totally could. And then you could just solve it that way. You could do that, yeah. I think this is easier than Monday as well. Monday we covered a lot of information. This is, again, it's nothing necessarily new to us. It's just putting it together. So I think Monday's is probably harder too, but that's okay. Better to be easier on the last thing. Okay. Let's do one more. And then I'm going to throw the last curveball at you guys. Okay, so we have, not in red, please. Remember we did this reaction. Let's say, what can we use for this? Yeah, let's use this. No, we'll use chlorine. Okay, yeah. Reacted in a tank with excess fluorine. The tank is 5 liters and the temperature is 325 Kelvin. How many atmospheres Yeah. Okay. Let's just leave it at that for now. Do you guys want to try this one on your own, or do you want me to kind of walk you through again? Yeah, because I'm making this thing bigger. Um, Hopefully that helps you out, and so that's why we have my face in the way. Yeah. So, because the way I used to do it is I would have it like this, and I would like plop this up here or something. So, but I figured it's a little easier on you guys if I make myself. Oh crap! Oh, I've lost it. Okay, look what you did, Zoe. I have to disconnect 1 sec so I can get my mouse back, put my face back, and now we reconnect. Okay. Okay, cool. Okay, so yeah, whatever. I'll just do it with you guys so you can you'll have plenty of practice with the homeworks and stuff like that. So, which one can we start with? We can start with the mass of sodium chloride, right? That's the one we can get moles from right away. What are we going to use? Well, see, that one was intentional, Rob. Like, I did that myself so I could get my cursor back since stupid Microsoft Kinect is a pain. But, whatever. We're going to use molar mass, right? 58.44. What's next? Coefficients, indeed. Which coefficients are we going to use? Well, of course, but like, what are the numbers, Elsa? So we're going to have 1 mole of chlorine and 2 moles of NaCl. So we got those from the reaction. Okay, doing this. 20 divided by 58.4 divided by 2. Okay, is going to be 0.1711115, whatever, moles of chlorine. Now what are we going to do? Indeed. So we are looking for pressure, right? That's atmospheres, yeah. So that's nRT over V. So we're going to put our 171115 moles, 0.08206, 325 Kelvin over 5 liters. Doing all this stuff. Gives us 0.91271 atmospheres, and it looks like we have 2 sig figs here, so 0.91 atmospheres. Whoops, did not mean to scroll away, sorry. Okay. How was that? I mean, so again, we're really doing the same thing kind of over and over again, but we're just using different units. So nothing should be terribly new here. Notice I could also ask you how many grams of Cl2? I could ask you that also. Does anybody tell me how to do this if I wanted to find grams of chlorine instead? Moles to grams, exactly. So we've got the moles here. Once we have the moles of the substance we want, we can use whatever things we need to do to get it into whatever unit we want. So we could say 0.17, what was it? 1115 moles times 70.90 grams per 1 mole. Isn't it sad how I have so many of these memorized? 0.171115 times 70.9. Okay. And that's going to be 12.13 grams. With 2 sig, or with, actually this time we can use 3 sig figs. So 12.1 grams. Okay, so just depending on what unit I ask for, you can do all sorts of things once you've found the moles. So, yeah, fun stuff. Nothing terribly new again, but just putting it in a different way. Okay, any questions on this one? Alrighty. I do have one new thing for us, which is, trust me, it's not going to be that bad. You should always worry, but that's okay. Here is Samvel's favorite equation, a combustion one. Let's see, looks like that's all we need to do to balance this. Lucky us. Time to throw. I'm going to just make up the numbers. Actually, it's probably bigger than that, but, well, whatever. Oh my heavens. Delta H is back. Uh-oh. I have a happy thing for you. So this is just... so this reaction is exothermic, right? How do we know that? How do we know this is an exothermic reaction? Yes, but how do we know that from this information that we're given here? The number. What about the number? It's negative, right? Negative delta H is exothermic, yeah. So we could write it like this, right? We could say plus heat on the outside. And so we can actually use this number as well as part of these calculations. So this particular number, this delta H thing, tells us we have negative 21,951 joules per 1 mole CH4. Or negative 21,951 joules per 2 mole oxygen. Or, I mean, you get the idea, right? This is the coefficient again. Okay, so if we are given, let's say we're given 100 grams of CH4, we can see how much energy that's going to be released when we burn this methane. That's going to be important for anyone who's going into engineering or anything like that. This is an important concept, and you'll be doing this lots in 101 as well. And thankfully for us, again, all we have to do is take what we're given and convert it to moles. So methane will be what, 16 point, I don't know, 0.3 grams for 1 mole, something like that. And then we just have to use delta H. Okay, so delta H tells us this number of joules over whatever your reaction coefficient is. So in this case, methane's was 1. So we just have to plug in the numbers. Let me finish up my units here. And so we can see that, as always, our units should cancel out. And so, doing this math, 100 divided by 16.3 times 21,915. I'm just going to make it kilojoules because it's a real big number. Yeah, that's what you'll get when you round it. Okay, so that's all that's there when you throw a delta H in. So we could figure out the amount of heat. We could also take this 100 grams and figure out the mass of carbon dioxide or the mass of water, or we could do the PV equals an RT of one of those. This is just one more component. So just remembering that we often have heat transfer as part of a reaction. So we could use joules as one of the quantities here. Okay, is that okay? The only thing you have to remember is it's always delta H is related to your reaction coefficients. So what would it be? What would our conversion factor be for water with this delta H? Marissa's going to give us the answer here. Let's see. She's not going to give us the answer. Oh no. Or I'm lagging, one of the two. Can anyone give me what the conversion factor is for water with this delta H? How would we convert joules into moles of water? If you have no idea, you can write you have no idea, just so I have some idea that I'm not completely lagged out. Okay, no idea. Okay, cool. So it's the same thing. It's just going to be 21,951 joules over 2 moles water. So it's the same number. The only thing that we have to worry about is these reaction coefficient things on the bottom. So what's it going to be for carbon dioxide then? And again, you can write no idea if you have no idea. Yeah, perfect, exactly. I have nowhere to write it, but you are correct also. That's how I would do it. So delta H is one number, and you can relate it to any of your reaction components by using your reaction coefficients. So let's see this in another light. Oh, this is boring. Let me make that sulfuric acid instead. So we can at least have some coefficients here. Oh, good lord. Okay. So, if 12,000 joules is associated, not if, with what mass of water? Another way to say this is if we wanted to release 12,000 joules, how much water would be produced as well? How are we going to go ahead and use this information? So we always want to start with what you know, right? The only number we're given to start is negative 12,000, right? Yes, you're absolutely right. And so what are we going to put? Yeah, it's essentially backwards, yeah. So what number is going to go on the bottom here? And what's going to go on the top? Mm-hmm. Yeah, absolutely. It's going to be 2 moles sample because that's from our reaction. It tells us we have 2 moles of water in this reaction, so we're going to put 2 moles of water with our delta H. Okay? And so, since we're asked for mass, I'm just going to go ahead and throw that in here now. Okay. Which is going to be 12,000 times 2 divided by 5,000 times 18.02. And so this reaction would also produce this many grams of water. Okay, so we can convert energy into mass as well using this method. Okay, sig figs looks like we've got, I guess, 4. So 86.50 grams. Okay. So again, the only hard part is remembering to use your reaction coefficient here. Okay, so again, I'll just kind of emphasize that. Okay, your reaction coefficient is the important part. All right, how was that? Questions on that one? Okay. I have to think now if I want to throw this next thing at you. I don't want to, but it is something we will have to cover. So, you want me to do it or not to? Do it next time, okay? Is that what you want, Elsa? You want it next time? So it would obviously not be on your exam or anything because I would not have taught to you. But maybe we could spend half an hour on the Monday before our final doing it. It's nothing new. It's just adding another layer of complexity. Okay, so in that case, this should be enough. So let me just check the homeworks because there's going to be some that you're not going to do then. So on homework 9, let's see. Okay, don't do, wow, lucky you. Only do the first 3 problems, okay? Wow, apparently that's in red for some reason. I got very angry at this 3 problems only. Or maybe Discord knew somehow that this was an important uh, announcement. Okay,
Can
so
you
homework
hear
8,
me?
do everything.
Professor G, can you hear me?
Yes.
So I've been typing in red for a while. I realized that it's like it's disconnected for some reason, the typing.
Oh, how strange.
So I was trying to ask a question a few times and it's just not working and I
Oh,
can't figure
weird.
out why.
Okay, well, who knows? Well, what's your question now that, I mean, you're welcome to ask
Oh, it
it.
was just it was a couple problems ago.
Oh,
So
no. Was it addressed or is it still kind of pending?
no, I'm trying to go back up to it. Hold on.
Okay, I can
Oh,
still
it
help.
was just I just said how do we get there from the beginning, and that was the question for Jesus Christ. It was a while ago, and I was trying to listen at the same time as doing all of that.
Yeah, yeah, sure.
Um, when you were talking about like how to get to H like 2H2O something like that, and I said how do we get there from the CH4? Do we convert the kilojoules like from the kilojoules to the H2O or
Okay.
but it's
No,
12 more.
delta H you will just actually put with whatever your reaction coefficients are. So
Okay.
if you can still see my screen, this would be the conversion factor you would use for water.
Okay.
It's the same number, just you use a different coefficient on the bottom.
Okay.
Okay,
Well, thank you.
that's it. That's it. There's no crazy trick to do it on this one.
Thank you. I appreciate you listening too. I'm sorry I
No,
can't
no.
type. It's
I'm
not
happy to listen. So especially since I mean we're done for today. So um, I'm happy if nobody else can someone else type something just if you guys can still hear me just to make sure.
I know
Um,
other people typed a few things in
okay, yeah, I
between.
can see them. Were you Sanville or Elza? Were you able to see my announcement about homework in Discord? No. Okay. So I guess I can't type either. Go figure. Um,
Yeah, we were both kicked out.
yeah, we're kicked out, so go figure. Okay, well, does anybody else have any questions on this stuff? I'll send that announcement out in an email or something, or I'll just type it later. Okay, so yeah, I would definitely practice this stuff. Do your homeworks. Let me just do one thing. Let me just restart disks just so I can. Oh, why am I doing logging out? That's silly. Let me just see if I can get this to type. Hmm. Okay, well.